Right, so my question is, does energy conservation preclude dualistic agent causality? Here's the outline of my talk. First, I'm going to draw a connection between agent causality, dualism, and libertarian free will. This just to locate the topic within the greater framework of this conference. Then I'm going to deal with the objection from energy conservation against interactive dualism. And I will try to present a proper formulation of this objection. Then I'm trying to present how modern physics in fact construes energy conservation. In the fourth section, it's going to be about investigating the empirical evidence that we have from neuroscience in the framework of volitional actions. And then in the last section, I'm addressing the question, what if energy is indeed conserved in brains? What are the prospects for dualism and for physicalism, respectively? Okay, so this first section just serves the purpose of drawing the connections between those topics. One could also address this topic by calling it interactive dualism without any connotation of agent causality or libertarian free will. But of course, the connections are at hand. And so I'm just presenting here my view, or just roughly my view about agent causality and its implications for free will, or its connection to libertarian free will. So my view is a very strong one. So it's very close to Daniel von Wachter's view, in fact. So in my view, the agent is influenced by reasons and desires and by inclinations, perhaps, as well, but in a non-causal way. So there is an influence, but it's not a causal. In no way is it a causal influence. And the agent brings about something, and I guess it's a brain event. So when you raise your arm, something happens in your brain first. I think that's straightforward. So we can speak of the agent bringing about a brain event. And now the question arises, of course, what is the relationship between the agent and that brain event? Is it a causal relationship? Is it a non-causal relationship? For example, an exercise of power, or some have proposed that it's a basic act. I'm not going to adjudicate between those views here. It's just that agent causality, in my view, means that the agent brings about a brain event. Or it could as well be, and in this case, that brain event would be what Daniel von Wachter calls a choice event. There is an alternative possibility, and I'm not yet committed to either of these possibilities, but nothing turns on that. There's also the possibility that the agent brings about not directly a brain event, but a mental event, which then in turn causes that brain event, and that mental event would be a volition or an effective intention. That's what it has been called by William Hasker, for example. And if that is the case, then the choice event is not the physical brain event, but a mental event. And of course, here as well, the question arises, what is the relationship between the agent and the mental event? Is it causal? Is it an exercise of power, or whatever? But again, nothing turns on that for the view that I'm trying to defend here. So, and freedom, of course, arises or is warranted in this view because there is no deterministic nor any indeterministic causation by those mental events on the agent. And also, the agent is the ultimate source, or you might say is a prime mover, is self-determined in bringing about that choice event here. So we have both criteria which normally are taken to be necessary for libertarian freedom. We have control, and we have the possibility of doing otherwise, because there is no deterministic or indeterministic causation here. Okay, and to supplement the whole thing, in my view, the agent is a soul, that is an immaterial substance that does all those things. So, and this is, of course, the view that I'm trying to defend here against the attack from energy conservation, or the purported attack, if it's any attack at all. That's my next point. What exactly is the objection? And if we look at the literature, it's not so easy to find a proper formulation of an objection. Because, for example, Daniel Dennett he sets out to say something about energy conservation and ends up complaining that how can we imagine that something immaterial as a soul acts on something material as a brain? What is the property that brings the physical events about? But that's, of course, a different question. That's a different problem. So that would be what others have called the causal nexus problem. So how can we formulate an objection from the principle of energy conservation? And my suggestion is as follows. Premise 1 is, if non-physical minds influenced brains, energy would not be conserved in brains. Premise 2, energy is conserved in brains with natural necessity. So I'm going to explain this term, natural necessity, so bear with me. And the conclusion follows validly. Therefore, dualism is false with natural necessity. So let me comment on premise 1. One might, of course, chime in here and say, well, why isn't an energy-conserving dualism possible? Well, it is. I think that there is a possibility for that. I can't expound on that very much here, but I think that the best way to formulate an energy-conserving dualism, if that is possible at all, would be with the aid of quantum mechanics. There are other dualist responses which try to uphold an energy-conserving dualism, but those are physically quite naive. Most of them end up just not attaining the goal they want to reach. For example, Jonathan Lowe proposed that the soul changes some physical constants and thereby brings about changes in the brain without violating energy conservation. But one can calculate that a change in physical constants would exactly bring about a change in energy, an unaccounted for change in energy, so that energy conservation would be violated. So he doesn't. He gets the exact opposite of what he actually wanted to get. So Brian Pitts and me, we wrote a paper just recently about those responses and analyzed them. So this is a viable option for a dualist, but I want to present an answer that makes dualism independent of quantum mechanics and independent of having to be energy conserving. Okay, premise 2. Now, the term natural necessity, why is that there? Again, I'm trying to distill from what anti-dualists say. I'm trying to get capture the spirit of their objections. And I think natural necessity is the best way to frame this. So John Searle, for example, holds, and I draw your attention to the bold printed sentence here. If substance dualism is true, then it seems that one of the most fundamental laws of physics, the law of conservation, must be false. So there's a clear dichotomy here. Either dualism is true or this fundamental law of physics holds. And I think that natural necessity is the best way to express what he wants to get at. Natural necessity is, roughly speaking, is that certain events are necessarily happen because of the laws of nature. Or David Chalmers says that there are two sets of properties in nature, in physics, that are strictly and perfectly correlated. For example, the pressure and volume of an ideal gas is strictly and perfectly correlated with the substance amount times the gas constant times temperature, just to give an example. But I think generally, the physicalist or the anti-dualist needs some kind of necessity to get an a priori argument going. That is, in order to sit back in his armchair and say, well, dualism is wrong because something in nature holds, you need some kind of necessity to say, well, this law is so fundamental, it just necessarily holds everywhere and at every place, so that dualism cannot be correct without, and you can say that then, without looking at the empirical evidence. That's the point. There are other types of necessity. So just briefly, I think logical necessity is clearly too strong here. So, for example, it's conceivable that energy not be conserved. We can just conceive that this chair just levitates in the air and without there being any cause for that. So that energy is, so to speak, appears out of nowhere. Perhaps there is something like metaphysical necessity, but I'm not sure that such a thing really exists. If it does, then it's stronger than natural necessity. And, well, I grant that the intuitions may differ here, but I think natural necessity is exactly what captures the spirit of the argument, because it says, because of a law of nature, dualism must be false. Okay, so one of my main points that follows now is that this conception of energy conservation, namely that it holds with natural necessity, is widespread, but it's a wrong conception. So how does modern physics, in fact, construe energy conservation? And just a little disclaimer here. So I'm not a physicist, but I really tried my best to get my head around this topic, and I took some tutorials with a PhD holder in physics, and had it checked by him. So I think it should make sense, but of course I'm always happy for comments and corrections by the physicists here in the room. So yeah, anyway. The first approach that one can take to get at what energy conservation is in modern physics is the Noether theorem, developed by Emmy Noether in 1918, which roughly says, informally, it's a mathematical proof, as a matter of fact, but informally it says that there is a biconditionality between continuous symmetry and quantities conserved over time. So now I know that sounds very abstract, trying to spell this out in a way that it becomes more plastic. That means whenever there is continuous symmetry, then necessarily there is a quantity conserved over time. And conversely, if we have a quantity conserved over time, for example, energy conserved over time, then there must have been a continuous symmetry in a physical system. So what I'm speaking here applies to defined physical systems. You can define it as you want. You can define this room as a physical system. You can define a chair as a physical system. That's a matter of definition. So continuous symmetry, that's a special case of symmetry. For example, a sphere is continuously symmetrical because you can just rotate it by an arbitrarily small angle and you still get symmetry. I think that's straightforward. Whereas a cube is symmetrical, but it's not continuously symmetrical because you would have to take 90 degrees rotations in order to get symmetry. Okay, and the other approach, and in a minute I'm going to fuse those two, is Lagrangian mechanics. A Lagrangian is an equation of motion, which is mathematical description of a physical system. And one can calculate, in fact, whether energy is conserved, or also whether momentum is conserved in a physical system by aid of Lagrangian mechanics. Namely, and with another equation, you need the Euler-Lagrange equation as well, and then it yields whenever the differential of energy over time is non-zero, then energy is not conserved. Only if the temporal differential of energy is zero, then energy is conserved. And that's in everyday words, it means that energy is conserved over time. So over a certain time span, energy remains the same in a physical system, and that's what energy conservation in fact means. Okay, but fortunately, we don't have to do those calculations here, so I'm not going to bother you with them. We can read off whether energy is conserved or not from the Lagrangian itself. Namely, as long as nothing explicitly depends on time in a Lagrangian, then energy is conserved. For example, take this very simple example. That's a particle in the gravitational field of the Earth. The Lagrangian reads like this. And we see that nothing explicitly depends on time in this term here, so energy is conserved. Whereas in this scenario here, where lowercase g, the gravitational constant, depends on time, explicitly depends on time, the Lagrangian itself depends on time and energy is not conserved. Again, just take my word for it now, one can calculate it exactly. This is just to make things a bit easier here. So what does explicit time dependence mean? I'm trying to just flesh this out a little bit. For example, it might mean that at point of time t1, the gravitational constant is what it is actually now, here in this place. And at point of time t2, that, for example, 20 minutes later, it drops to just half of it, or whatever other value. It just changes just as a function of time. That's explicit time dependence. And if that applies, then energy is not conserved over time, because clearly the energy of that particle in this scenario is different from the energy here, but the only thing that has changed is time. So that's an explicit, that's a time dependence of energy, and so energy is not conserved over time. What does all this have to do with dualistic interaction of souls on brains? Well, normally we don't observe that. We don't observe sudden changes of constants of nature. And I think, as I said before, I don't think that any soul does such a thing. But we also don't normally observe merely time-dependent changes of physical quantities. So just as a matter of time, nothing like charge, velocity, mass, or something like that just changes. But it is conceivable, I'm going to present an example for that they do, that is, that they change, dependent on time, where and when a non-physical entity acts on the physical system. So just to illustrate that. This red sphere here is a physical entity with a normal Lagrangian description, with mass and velocity and so forth. And this blue thing here symbolizes a non-physical entity. Let this be a soul, right? Okay, so this thing moves in this direction, indicated by the arrow. And now comes the trick. This thing here is, of course, not a physical thing, so it does not get any physical description. But ex hypothesis, it must be causally efficacious. That's the hypothesis of interactive dualism. Okay, and now, of course, I put the word collision in quotation marks because when they two, so to speak, move towards each other, so here begin the difficulties. We cannot speak of this thing moving, the blue thing, really moving towards the red sphere, and we cannot speak of a collision either. So don't take this literally, but what is necessary in order to investigate the dualistic hypothesis is that the blue thing is causally efficacious, so that the red sphere will bounce off or will change its direction and will change its speed due to an interaction with this blue thing here. That's important to uphold. However, this causation in fact works. That's a different, interesting question. I'm not going to address this. I'm just taking this for granted. And what happens is that the speed of this red sphere here will change. It's like taking a tennis ball and hitting it with a tennis racket. So obviously the speed of this tennis ball will increase. That's exactly the thing that happens here. But by contrast to the tennis racket example, we cannot formulate a common Lagrangian of the sphere plus blue wall, soul, whatever thing, because this blue thing is not physically describable. So it's not part of the physical system. And so the physical system, in fact, consists only of this red sphere. And if we look at the energy will increase. So it's greater at T2 than it was at T1, which means that the energy is not conserved over time in this physical system here, which means that energy conservation does not hold here. Or, in Lagrangian terms, the velocity depends explicitly on time. So what does all this tell us? Well, for one, that energy conservation is not naturally necessary, but it's conditional on time translation symmetry. That's a consequence of the Noether theorem. So if time translation symmetry holds, then energy conservation holds. If it does not hold, then energy conservation does not hold. So, and what I also try to present you is that it is conceivable. We can construct a meaningful and sensible scenario in which energy is not conserved due to the interaction of a non-physical entity on that system. So, and this corresponds to buttress this whole thing a bit further, is that it corresponds to the a priori reflections that Daniel von Wachter gave us this morning, that S1 will be followed by S2, those two events, if nothing is counteracting S1. So energy, you could translate this and say, okay, energy is conserved only if there is no counteracting non-physical entity that works on that system. So, just not to get misunderstood, what I'm not saying is that this is exactly the case, that interactive dualism is being proven by those arguments. I'm just saying that it's plausible, it's conceivable, and so far nothing decisively speaks against it. So no a priori argument is possible. So the physicalist can't just relax in his armchair and say, well, because energy conservation holds, dualism must be false. What he has to do is to look empirically whether in fact in brains energy conservation holds or whether it does not hold. And this, by the way, opens up to dualists the so-called conditionality response, namely that energy and momentum are conserved whenever and wherever only physical causes are at work. But if, or whenever and wherever a non-physical cause interacts with a physical system, then energy and momentum are not conserved. And this response does not depend on quantum mechanics, does not depend on interpretive issues of quantum mechanics, and does not commit the dualist to uphold an energy conserving view. So, let's look at the empirical evidence now. So what do we have? What does neuroscience tell us? Because there is still the real possibility that, in fact, neuroscience finds out that there is a complete physical explanation for everything which conserves energy, and which then, in turn, would bring the dualist in trouble. And Montero and Papineau, for example, they seem to think exactly that. They say it was the empirical evidence that persuaded philosophers to be physicalists. And they continue and say, all effects have physical causes, even in bodies and brains. So they specifically apply this claim to bodies and brains. So one might formalize their point in an argument that goes roughly like that. Dualism implies that at least one brain process is not explainable physically, and that therefore energy conservation is violated. So just to make it clear, so physical explanation and energy conservation go hand in hand. So whenever I have a complete physical explanation for a system, a change in the system, then energy is conserved. But if the physical explanation fails, and for example a non-physical explanation applies, then energy will not be conserved. Premise 2, all brain processes can be explained physically and conserve energy. and therefore dualism is false. Okay, so let's look at this claim. Is this really the case that in bodies and brains, all physical effects have physical causes? So what I'm looking at is the empirical setting of volitional actions. It has been studied quite thoroughly by neuroscience, and of course this is the pertinent agent causalist scenario, because we want to look at scenarios in which the agent willingly does something. And of course, if an immaterial mind has any causal influence in the world, then it is perhaps in those scenarios. So roughly 10 years ago, Patrick Haggard published a review of the current neuroscientific knowledge about volitional actions, and the picture is roughly as follows. That's a sequence of events. So neuroscientists were able to trace the brain activities up to 10 seconds prior to the actual muscle contraction. So it seems to begin in the basal ganglia, then continues through the prefrontal cortex into the pre-SMA. SMA stands for supplementary motor area. Then comes the SMA, then the primary motor cortex, and from there it goes straight into the spinal cord and then to the muscles. So what are we talking about when speaking of activity of brain regions? Well, we're speaking about activity of neurons, but we mustn't understand it by a neuron being in a state of complete rest and then transitioning into a state of activity of firing. That's not the case. Rather, it is the case that those neurons are already in a state of firing. They fire with a certain baseline rate. And in correlation with the volition and the volitional action, this firing rate goes up. That's just as a background information. Okay, so does it matter whether volitional actions begin brain-wise in the basal ganglia? I submit it does not. If it's not the basal ganglia, then it's some other brain region prior to the basal ganglia where all this commences. No matter what brain region it is, some brain neurons will be the first ones to increase their firing rate. And I will call this region where those neurons first increase their firing rate the neurocausal origin, or NCO. Now, one might think of this process as roughly chain-like. And in this case, we have some first brain neurons that must have been triggered to increase their firing rate by something else than brain neurons, obviously, because the chain cannot go on forever within the brain. It must lead out of the brain. But of course, one might construe this process as something circular that takes place only within the brain. Then we might have something like circular causation, and I will come back to this at the end. But let's first stick with a chain-like picture of such a causal process leading to volitional action. The NCO might be a classically physical event. For example, a neurotransmitter binding to a receptor in a pertinent neuron and then triggering some action potential and then going its way to the muscles. Or it might be that's, well, admittedly that's speculative, might be something quantum mechanical. Like I'm coming back to this, but it's roughly the idea that some particles have indeterminate position and or momentum, and that therefore they might trigger some macroscopic event without there having been a prior physical cause to make those particles cause their effects. So the question is, what makes the neurons in the NCO increase their firing rate? So, and the first point I want to make is that there is no positive, to my knowledge, no positive empirical evidence or explanation yet been given in the literature. I can't see that anyone came up with an explanation and said, oh, I found out that it's it's such and such hormone that binds to some receptors in the neurons in that region, and this gives rise to the causal chain. If you know anything of this kind, then I'll be happy to learn it. So, contrary to Monteiro and Papineau's claim, there apparently is no positive evidence for a complete physical explanation of all brain events. So we have to change the question. What physical cause might make the neurons at the NCO increase their firing rate? So I'm just hypothesizing now. So that's normal picture. Normally, one neuron, in this case N1, is triggered by N0 in case an action potential travels down the axon and leads to the release of neurotransmitters here at the synapse, which then bind to the dendritic receptors and give rise to another action potential, and so on and so on. It's like domino bricks, yeah, in a very simplified manner, of course. If we zoom in, then the picture gets a little more detailed. Those little dots here are the neurotransmitters, and the movement of those vesicles in which the neurotransmitters are bound is due to the opening of some voltage-gated calcium channels, which react to the action potential that arrives here. And some calcium ions flow in and then cause the exocytosis of those vesicles. That's the normal way how neurons are made to fire or increase their firing rate. So a first idea how this could be explained would be what I call a closed sensory motor causal chain. That is, for example, let's assume that we see something, and then we have a complete physical explanation of photons reaching our retina, changing the conformation of some proteins there, which leads to some nerve impulses in the optical cortex, and which in turn causes within the brain, in an uninterrupted causal chain, causes my muscles to contract. That would be a possibility. And perhaps there are such actions which are just triggered by our seeing, hearing, smelling, whatever, something. This is very intriguing and enticing, but it's not plausible, unfortunately, because we know of optically triggered actions, but they have a different neurophysiological pattern. In particular, the SMA is hardly, or it's not involved at all in those optically triggered actions. And secondly, experiments have been carried out with pure mental simulations. That is, subjects were sitting in their chair and they had their eyes closed and their ears closed, and they were just carrying out mental simulations of motor actions. So they weren't even carrying out the muscle contractions, in fact, but just imagining them. And that led to almost the same firing pattern as actual volitional actions do. And that suggests that that optic or sensorically triggered actions are distinct from what we call volitional actions. So if this possibility is barred, then what else could we hypothesize? There are some cells which are called pacemaker cells. Those are cells which fire very regularly, like this. We have those cells in the heart. We also have those cells in the brain. So it's plausible that, and they don't need any synaptic input. That's important to stress here. The question is it plausible that such cells initiate volitional actions? Well, for two reasons it's not. First, the regularity of those action potentials is somewhat in tension with the occurrence of volitional action in the real world. And also those cells are not involved in volitional actions. They are not involved in motor initiation. They are more involved in things like hunger and satiety or wake and sleep cycles, things like that. So this seems implausible. Another hypothesis is what I call the endocrinal hypothesis, which is that hormones bind to the receptors here. Hormones are of non-neuronal origin. They're different molecules coming from endocrinal glands. we know of no such example that is involved in volitional action. They take place in other contexts. And also, again, the role of hormones in the body is a different one. It's a modulatory one, not an initiating one. So that's implausible as well. What remains are protein conformational changes. So we have different loci here around the neuron where proteins, if they change their conformation spontaneously, could lead to a release of neurotransmitters or to an action potential. All of them require energy because a protein does not change its conformation without energy input. It just doesn't happen. So what might make those proteins change their conformation? Well, one possibility is to posit, to stipulate some molecules that are not hormones, that are not neurotransmitters. For example, we know that if drugs are administered to people, then something changes in their synapses and, deviant behavior results. But, well, I have no idea what this could be in the context of volitional actions. Then, another hypothesis that I just figured out is what I call outlier molecules. So what I mean by that is we know that temperature is an expression of the mean kinetic energy of molecules. That's what statistical thermodynamics tells us. So there are always, at a certain temperature, there are certain molecules far above or far below this mean kinetic energy. So it might be that there are some water molecules around which have very high kinetic energy, which collide with the proteins and just cause a conformational change. Well, this might indeed be an interesting explanation for accounting for the baseline. Remember, neurons always fire at a certain rate. But if it accounts for the baseline, it can hardly account for the increase in firing rate. And also, the problem is that suddenly many of those outlier molecules would have to come about somehow and trigger many proteins to change their conformation. And it's not clear how this can come about. So one last resort, it seems, is some kind of cyclical explanation. So, in other words, an activity in the brain that always takes place in a circular manner. For example, something that has been installed in our brains during embryogenesis or during birth and then continues throughout our lives. A regular energy exchange in the brain that never is interrupted in any way. That would then conserve energy, of course. But this is, of course, highly speculative. I don't know of any such account. We have no positive evidence. And it seems that if this is true, then our intentions or volitions would be either incredible coincidences with those, that energy just going in this direction of the brain or in the other direction, or if this is not the case, then those mental events would just be epiphenomena, something, a byproduct of those physical goings-on. But epiphenomenalism, I take it, is wildly implausible, and I think Richard Swinburne has showed this very convincingly in his 2019 paper. So the resources become scarce now. What remains is quantum mechanics. Again, this is the idea of molecules moving spontaneously within the confines of the Heisenberg uncertainty relation. One question is whether such effects are strong enough. Friedrich Beck and John Eccles think they are. They came up with some calculation, but David Wilson thinks otherwise. He also came up with other calculations, so presently it's unclear which one is right. And also, again, we have a problem with the probability distribution, because the probability distribution of quantum events would have to coincide with volitional actions and free will in some way. And I'm not sure this is viable. So this is a possibility, but it's not problem-free, as you can see. So to sum up, we have no empirical evidence for a complete physical explanation of volitional actions. At least I can see one. If we conjecture and say, okay, what might be a physical explanation for volitional actions, then all seem to be in some way or another problematic, unconvincing, or speculative. Perhaps the pacemaker cell idea and the quantum mechanics idea are the best ones. So there's at least a possibility that complete physical explanation with respect to volitional actions fails. If it does, if it fails, this doesn't mean that dualism is then proven, but it is supported, of course. But the problem for physicalism is that it's refuted, because physicalism is very demanding. It claims that every physical effect has a physical cause, and if we can find at least one physical effect that clearly has no physical cause, then physicalism has a real problem. One might therefore even turn the tables and construct an argument against physicalism. I'm going to skip this and spend some time on the last section. So what if energy is conserved? Because all I have tried to show here is that in principle it would be possible that physical explanation fails. But what if indeed some physicists in the future come up with an energy meter which measures the energy changes in the brain and assures that in fact, considering all the events that take place, considering that the brain is an open system and all that, would yield the result that energy is conserved in brains. So what if physicists came up with that empirical result? In this case, one would have to ask, what is the nature of the explanation? Is it that we have a classical explanation, as I just sketched before? Or do we have a quantum mechanical explanation for the energy conservation? In the former case, as I said, dualism, no, sorry, I didn't say that. But if there is indeed a classical explanation, then physicalism would be vindicated, because that's what physicalism claims. And dualism, in turn, would have a real problem, because then what's the role of the immaterial mind? If we have a complete physical explanation, it seems that the causal role is somehow superfluous. But in the other case, if the explanation is quantum mechanical, then the situation doesn't seem to be all that clear, because both metaphysical views have their accounts. I sketched the physicalist one already, and dualists could make use of the same thing and just add to that the material mind is responsible for influencing some quantum event, for example, making the collapse of some wave function happen, if that indeed is what happens, and so forth. And this is an interesting research topic. This is the second building block of my thesis. But at present, I don't want to adjudicate between those two here. At least dualism would not be refuted. This is what we can state, I think, right now. So, to wrap up and to come back to the question, does energy conservation preclude dualistic agent causality? Well, at least not in an a priori manner. So I try to show that the physicalist cannot just sit back and say, well, energy conservation holds necessarily and therefore dualism is false. Perhaps if energy conservation would indeed hold, then dualistic agent causality might be precluded or refuted if we get some empirical evidence for that. But then only if this energy conservation held due to a classical cause. All right. In the case of a quantum mechanical cause, dualism would still be compatible with energy conservation. So, and at the end, I just want to make some acknowledgements. I want to thank, of course, the John Templeton Foundation for funding the project at the IEP and my salary for the last 2 years. I also want to thank Daniel von Wachter for the courage to support me as a PhD student, which does take some courage. And I also want to thank Dr. Brian Pitts, which is the physicist that I mentioned before. He just invested a lot of time teaching me physics. It was very worthwhile. And I thank my colleague Christoph Mocker for many inspiring conversations. And I thank you now. Thank you.
Thank you for the interesting talk. I have a huge number of questions and objections. If you, first of all, if you don't have a mechanism of how a non-physical agent interacts with a physical entity in the brain, how can you say something about energy is conserved or not in this process? That's the first question. Second question is, you didn't talk about the empirical question of measuring energy. So in order to transfer information, very minute amounts of energy are necessary as compared to leaving a hole in the garden or something like that. So there may be also another possibility that the amount of energy needed for information transfer is so minute that you have no chance to measure it. Mm-hmm. Okay. How do you deal with that?
Okay, let's take the first question first. It was about a mechanism. Well, I don't think that I need to give a mechanism. Well, that's desirable, of course, to get such a mechanism, but I don't think that's necessary for saying that stating that energy is conserved. Because if it would be possible to measure energy conservation or non-conservation in a different matter, so to speak, like take the brain to be a black box, and you could measure all the influxes and outfluxes of energy, and you could ascertain that indeed energy is conserved or is not conserved, then no matter what happens inside that black box, we could say that energy is conserved or it's not conserved. So I don't think that a mechanism has to be given in order to answer that question.
No, the thing is, why do you assume that energy is not conserved with this interaction? The interaction may be that always pairs of states are changed in a way that the sum of the energy is conserved, but the details say neuron 1 shifts and loses 100 milli-electron volt, neuron 2 shifts and gains 100 milli-electron volt. So the agent causes the information exchange by this mechanism, so the sum of the energy is conserved. This could be whatever kind of mechanism, yeah? But how can you assure that it would require energy to interact for the soul with brain?
You're speaking of energy redistribution within the brain?
For example, whatever there is. Yeah? I'm just saying you don't know the mechanism, so why couldn't there be a mechanism that transfers information without transferring energy?
Right. I'm not so sure about the notion of information now, but one problem with energy redistribution is that it probably violates momentum conservation, as far as I can see. So it's just not possible to have, for example, let's take a particle that's on its way to a certain receptor, to a synaptic receptor. And suddenly, the energy of that particle remains the same, but it's somehow redistributed such that it travels now to another neuron nearby and binds there and causes another brain event. So that would be a case of energy redistribution. So we have the same amount of energy, but something changes, and that's linear momentum, as far as I can see. So, and that's not less a problem than the energy violation, because then momentum would be violated. So it's not all that easy.
Sorry? You have no chance to measure it.
Well, that's still a distinct problem. I agree with you that it might be, so to speak, epistemically difficult to measure such minute changes. But I'm not, well, in principle, if it could be measured, then we could even know about that. But in principle, it's what it just tried to do was to say that the energy conservation, the fact that energy conservation holds normally in most places, does not entail that it necessarily holds in the brain, and such that dualism of this kind cannot be true. It could be the case that the dualistic mind violates energy conservation within the brain. This is just a possibility. I'm not saying that this is the only possibility, but it is a possibility. So it frees the dualist of restricting his answers to a very narrow range.
I think measuring the violation of energy conservation should be pretty simple. You just measure what you eat and what you breathe and how much heat you produce. And if you produce more heat than warranted by the energy you have taken in, then there is some additional energy input. So it's not that hypothetical to measure it. And the second point is, like Ralph Bergman said, I don't see any reason why energy conservation should be violated when I make a decision as an agent. And similar to what he said, I mean, I can make you do many things without transmitting any energy to you. Just putting up a sign, fire in the room, please evacuate immediately. Everybody runs out, but the energy comes from you and not from me transmitting some energy to you. And I think your picture of the processes in the brain are somehow classical, integrable, well-behaved, stable systems. But what if the brain is on a constantly unstable trajectory that could at any moment in time run off in many different directions? Then I think your considerations are not valid. So it can run off in many different directions, and maybe I decide in which direction to run, but they all have the same energy. And
yeah, that would be something like the
points of instability, and world of real physics is full of many instabilities. So
So I agree with you. That would be a clear possibility. If this would, I think this aims at something like a quantum mechanical approach. Says that there are certain possibilities open, which all have the same energy, and the mind would be then the one who decides which path to take.
I'm not sure you even need quantum mechanics. You can have a classical picture of unstable trajectories that have all the time run into unstable points where they can go in different directions.
Yeah, I'm totally happy with that. And I'm also considering those accounts in my work. It's just I just wanted to make clear that this long-standing objection does not work. This a priori objection does simply not work.
At one point in your talk, you said that physicalism entails the thesis that every physical event has a physical cause, right? Every physical event has a physical cause. Now, modern physicalists are more careful than that.
I know.
Every physical event that has a cause.
That has a cause, yes. I know. So it doesn't make much of a difference because, then you would have to say, okay, there may be some physical effects that have no cause, and what would that be? I mean, what is interesting are the physical effects that have some cause. I mean, that's interesting for the physicalists. I don't think the other one, what would that be? Ontic chance? I don't know.
Traditionally, physicalists have no problem at all with chance events, with absolute chance events that have no cause at all. Another thing, at one point you correlated physical explanation and energy being conserved. Now, to the best of our knowledge, some physical events have no physical explanation. Take the decay of a radium atom, but energy is nevertheless preserved. Physics has no reason at all to.
Totally agree with you. That would count as a complete physical explanation. I tried. That's why I made this dichotomy between classical explanation and quantum mechanical explanation. So that counts as a physical explanation.
What?
Of course.
Having chance doesn't explain anything. It means the. Well, probability is no explanation.
Right? I mean, in this,
Well, I am not denying that, but if you calculate the probability, that doesn't mean you have explained the event, right?
Okay. Yeah, I get your point. I get your point. Explanation. Nothing turns on that expression.
Right.
The point. My point was that you have some causal, some process that accounts for those events happening in the brain, which conserves energy. And I think let it be some decay, some other quantum event, that would be a physical event that, whether it has an explanation or not, it gives rise to a causal chain subsequent, and this would be some kind of, you might call, I call it an explanation, even if the first event does in a very narrow sense not have an explanation. But that's not the point. The point was to say that, okay, energy might be conserved, and we have those volitional actions. What might physicalists come up with as accounting for that?
At the beginning of your talk, you listed some possibilities for the relationship between agent and brain event. And one item was causal, and the other was exercise of power.
Yes.
And I wonder what is the difference? Isn't it so that if I cause something, I always exercise some power? What's the difference between the two?
Yeah, that's a good question. Well, actually, I'm also wondering about that. In the literature, you find people speaking about the agent causing a volition, and the others saying that this is they bring it about. It's just an exercise of power. This is a very well. Means going very in deep into the details. Maybe it's just a terminological issue, in fact. So. I would prefer to have an account that just says we are speaking of agent causality, and whatever the agent brings about, whether it's via exercise of a power or whatever you call it, he causes that to happen, always with the proviso that it's totally dissimilar to, or it's sufficiently dissimilar to event causation. So the agent is, so to speak, the ultimate source of that event, whatever it is, and was not caused by some prior events or some prior entities to cause that event. I think many of the problems stem from people wanting to avoid causal talk because they fear that then this infinite regress objection comes up, which says that what made the agent cause his causing. And I think since some agent causalists want to avoid that, they they avoid talk of causality at all. But I don't think this is necessary.
Again, it's both the glory and the drawback of a conference like this, that we have papers with so many things to comment on. But just one thing to pull out. I'm wondering about the significance of the distinction between a global and a local conservation law. And the reason is that, as I understand it, the conservation law is set up to apply to a kind of idealized, isolated system. And in practice, they're never actually fully isolated. But the way that we get around that is we say, well, for bookkeeping reasons, we'll consider the entirety of physical reality to be an isolated system. And at that point, to measure the conservation of energy, you're going to have to measure the energy pouring out of quasars halfway across the universe at a level where you're measuring tiny fractions. That, you know, it's pointless to speak at that point of measuring it. We adopt these things as theoretical conventions. They help our bookkeeping. When I wiggle an electromagnetically charged particle over here and then I don't see anything happen for a while and then something happens over there, I say, oh, well, the energy was in the field somehow, right, in order to make sure that I don't lose out on that. But when it comes to measuring the brain, it seems to me that there would always be an out to say, well, but you know, really no brain is an isolated system. That was just an approximation for idealization purposes.
Yeah, very good point. As far as I understood Brian Pitts, in fact, it is the case that modern physics considers localized systems and doesn't even have to idealize those systems as being closed, but just considers the system and defines boundaries for that system, and then via an integral can calculate all the energy density fluxes and energy fluxes across the boundaries of that system. So whatever goes in, whatever goes out is being considered in a huge mathematical term, and via that approach, they can mathematically, at least in principle, ascertain whether energy is conserved in that boundary or not. And precisely, they do not have to consider the whole universe as a system. As far as I understood, Brian, there are some problems even with getting a space over which I can draw that boundary for the whole universe and calculate the energy conservation. There are some cosmologists who say that's not even possible because perhaps the universe is an infinite Euclidean space and we cannot even meaningfully define energy for that kind of space. So I'm not an expert on that, but as far as I understood him, it's not univocal among physicists that we can even make sense of a global conservation law. So that's why they considered only local conservation laws and say that the global conservation law would hold if we could integrate over all the physical systems within the universe. And therefore, it doesn't matter whether the brain is a closed or an open system.
Well, thank you for a very challenging and interesting lecture. And of course, I would agree with your main point that the principle of the conservation of energy cannot apply to the brain if we assume or experience that we have a free will that leads to movements and to changes in the brain. But I think the philosophical critique of this principle is much wider because, first of all, I think, in my opinion, philosophically speaking, the notion of energy is an extremely confused notion. What is energy? And the Einsteinian formulation that energy is mass times the square of the speed of light doesn't throw any light to what, philosophically speaking, energy is. So then what is the equality of energy, for example, between kinetic energy and the warmth, like if the development of energy was originally by the observation that a ship that moves changes the temperature of water. But, I mean, why is it that the same energy in the ship is preserved or conserved? Or take of electric energy. The waterfall has a kinetic energy, but if it does not drive a turbine, then certainly there's less energy in the world than if there's a turbine and an electric power that moves all electric motors of new cars in the world and all computers and so on. So I think it's generally very difficult to claim that the energy in even in a closed system remains the same independently of what kind of machine is used, what kind of process is given rise by some movement or by some warmth. So I think therefore to claim this conservation of energy is already in general in pure physics extremely unprovable. It's a postulate, but what concretely it means can perhaps be verified in certain limited areas, but I think as a general principle of the whole physical world, I think it cannot be sustained. But in life, I think it is clear Schrödinger, Nobel laureate for physics, in his book, What is Life, precisely says that as soon as you have life, you have an absolute opposite to the principle of the conservation of energy and to the principles of the first principles of physics, of entropy. And he argues that of course, like if you have two cells at the beginning of human life, and then you have in 9 months millions and billions of cells, and they grow and they all kinds of vital energies, then how can you claim that the energy is preserved? So in the entropy, it's the anti-entropy, because the living being creates more complex forms of energy all the time. So I think as soon as we have life, the principle of conservation of energy is already not applicable. But when you have persons and free will, I think it is altogether inapplicable. And therefore I agree with you, but I think maybe the critique of this principle, application of the principle of conservation of energy to free will could start much earlier and be much more comprehensive.
The question what energy is, in fact, is a very, very deep question. And I'm just citing again my esteemed colleague Brian Pitts, he said to me that energy is just a bookkeeping device, actually. I don't know if that's right, but anyway. And the other thing is that, well, I do think we have good reason to assume energy conservation in nature, not only because we observe it so often that we can inductively infer to other situations, similar situations, and say, well, it held in all those situations, and then it will also hold in the other situations. But also, there's a stronger mathematical claim here going on in the form of the Noether theorem that suggests that indeed, that as long as nature is uniform over time, then energy will be conserved. Only if this uniformity is broken at some points in time, then those quantities will not be conserved. And I think that's precisely what we want to have. We want to have the possibility of interaction by souls and by God, but we also, I think, well, at least I want to uphold that a regularity of nature is sufficient, but not, it's just sufficient, but it's not too much. It's not precluding then any intervention. And well, I agree with you that phenomenally, it does seem to us that agency is something that cannot be constrained by energy conservation, but this has to be treated very carefully. We really need to look at the brain, what happens there. Is energy really conserved? Do we have physical explanations? But I still think, and that's my view, that the best response a dualist can give is that indeed, when a soul acts on the brain, then energy is not conserved in the brain. And the violation will be very small. It may not even be measurable, perhaps, but I think that this is what is going on.